The boy tries to pick up the girl in geometry class by saying, "What's your sine? It must be 90 degrees because you are the one." And that pickup line will sound a lot better after I explain what sine is, as well as cosine and tangent. So the sine ratio describes the relationship between the angle and the ratio created by the opposite leg and the hypotenuse. So all you have to do is take however long the opposite leg is. So that's a length. And you put that over the hypotenuse, which is also a length. And if you took sine of an angle in your calculator, it would give you the same number as just dividing the two sides. So a long time ago, people would actually have tables of these ratios because not all triangles are the same size. But if the ratio is the same, we can use similarity to figure out those relationships for different sized triangles. The cosine ratio is very similar. It describes between the adjacent leg and the hypotenuse. So it's the adjacent leg over the hypotenuse. One thing to remember, which one's the adjacent, which one's the hypotenuse, which one's the opposite. Whatever angle you're taking, and we almost never use 90 degrees, okay? Avoid 90 degrees as your angle. Okay, so you're using something besides 90 degrees. So you take that angle on a right triangle, and the side that is not touching it, the one that is across from it, that is opposite. So this side is opposite that angle. Now, we have two other pieces. We've got a leg and a hypotenuse. The hypotenuse is never one of the legs. So you can see it always goes on bottom for sine and cosine. The other leg, which touches the angle, is the adjacent leg. All right? Usually what really helps is to draw an arrow from the angle to the opposite leg, so you always know which one's the opposite and the other one's the adjacent, and the hypotenuse is the longest side. And the hypotenuse is opposite the 90-degree angle. Okay? The tangent ratio is also similar, and it's the ratio just between the opposite leg and the adjacent leg. So the side opposite the angle right there. So it's the opposite side over the adjacent side. Okay, so let's go ahead and we're going to use some of these special right triangles we've already studied to look at what some of the ratios might look like. So we're going to practice identifying opposite and adjacent legs and the hypotenuse. So here are the special rights that we have and that we've learned about. There's the 45-45-90 and the 30-60-90. So when I have a 30-degree angle, I don't want to use this 45-45-90. I want to use this triangle because it has 30 degrees. And what's the opposite leg on this one? Well, that's going to be 1. What's adjacent to 30? That's the square root of 3 leg. And the hypotenuse will be 2. So if I wanted to do sine of 30 degrees, not 60 or 45 or 90, if I want to do 30, I have to use the side opposite the 30 over the hypotenuse. Cosine is going to be the side adjacent to the 30 next to it over the hypotenuse. And tangent is going to be the opposite side leg over the adjacent leg. Okay, now let's take a look at 60 degrees. Well, the opposite and the adjacent aren't the same for 60 degrees. The leg opposite the 60 is the square root of 3. So I'm going to write that down there. The one adjacent is the 1, and the 2 is the hypotenuse. It's never a leg. Okay, so if I do sine of 60, it would be opposite over hypotenuse, square root of 3 over 2. If I do cosine, it's adjacent over hypotenuse, or 1 over 2. And finally, if I do tangent, it's opposite over adjacent, or square root of 3 over 1. Finally, I'm going to do 45 degrees, which is over on this other triangle. Doesn't matter which 45 I use because they're both the same. So the opposite leg is 1 and the adjacent leg is 1. So here, it's not as big a deal. The hypotenuse is square root of 2. So if I do sine, it's opposite over hypotenuse, or 1 over square root of 2. Cosine is adjacent over hypotenuse, which is 1 over square root of 2. They're the same for 45 degrees, which makes sense because you can switch the angles and it looks the same. And then finally, tangent is opposite over adjacent, but those are the same. So it's just 1 to 1. So what about 90 degrees and 0 degrees? So if I want to look at something, the sine and cosine of things, what I did is I made this virtual triangle, and I can make the angle very low down to 0 and very high. So when I'm here, let's go here. When I'm at 60 degrees, you can see this side is 0.5, this leg, and that leg is 0.87. All right? So that's okay. I've got numbers here and there. If I went at 0 degrees, the opposite leg would be 0. And the adjacent would be 1, even though you can't see it. So 0 over 1 is 0. So sine of 0 degrees would be 0. And cosine would be 1 over 1, which is 1. So that's an interesting value, not something you really have to memorize. And then finally, let's go ahead and go to 90 degrees. What happens at 90 degrees? Well, the opposite, believe it or not, it's probably hard to see, will be 1. Okay, and the hypotenuse is 1, so sine of 90 is 1. But the adjacent is going to be 0. So cosine of 0 degrees is, cosine of 90 degrees is 0. So sine of 0 is 0, sine of 90 is 1, cosine of 0 is 1, and cosine of 90 is 1. These are not things you have to memorize. You can put them in your calculator. But later, when you study pre-cal, you're going to find out these are very important points. And this is also the reason we never use 90 degrees in our right triangles, because we're always going to get 0 or 1, and that's not going to be very helpful to us. So for further reflection, explain why sine of x can never be bigger than 1, and what is the relationship between sine and cosine for complementary angles. Also, can you think of a time when you can't calculate tangent of x? So if you looked at that one where I looked at 0 degrees and 90 degrees, one of those won't work so well for tangent. See if you can figure it out.